Video number 173, linear and angular speed formulas. The first formula is something we're familiar with. Velocity equals distance over time. Just think about miles per hour. Miles divided by hours, distance divided by time. Okay. This is speed over time. Okay, now, if we use arc length in radians, we can say that this referred to as angular speed equals theta over time. How do we know that? Because, oh, excuse me, S, that's not speed. This is D. S stands for what? Arc length, arc distance over time. Then if we say that theta is the length in radians, we can call the angular velocity, angular speed, equal to that distance over time, which is theta over time. Now, things get interesting. Because then arc length can be found by arc length S equals radius times theta. Make the substitution. Therefore, velocity equals R times theta over time. And then you can rewrite this as theta over time, which of course is angular speed. Therefore, we can substitute and say that velocity equals R times W. R times the W. See that? You can throw this in for W. W in for theta over T. So we have an angular speed and a linear speed. Okay? Now, so here's what we're doing. We have a way of taking the angular speed and converting it to how fast somebody would be going if it was in a straight line. That's what's cool about this. Point B is on the circle, and ray AB is rotating with angular speed W. That's point A. Point B is on the circle and it's rotating. All right. For the given values, find each of the following. Number 1, angle. 2, distance. 3, linear speed. All right. To find the angle, we're going to take W equals theta over time. Theta, we don't know. We're going to try to find theta to find the angle. We know what W is. It's pi over 10 radians. Okay. So then we substitute pi over 10 in for W. Cross multiply. Bam. Theta equals 2 pi over 5. Now we're going to come back and use this in a moment here. To find the distance traveled, we can now use arc length formula equals radius times theta. Then of course we know what theta is. We know that theta equals 2/5 pi. There's your radius, because they told us the radius is 30 times 4 seconds. Now, multiply all this together. That becomes a 6 times 2, which is 12. Therefore, 12 pi centimeters is the distance that this arc length is. Now to find the linear speed. So we're going to take this arc's distance, and we're going to find the speed if it was on a straight line. Okay? And the velocity is equal to distance over time, arc length over time. We know that arc length is 12 pi, time is 4 seconds, 12 divided by 4, 12 pi, 12 divided by 4 is 3, so therefore 3 pi centimeters per second, which is 9.4248 centimeters per second. Good times. Any questions, send me an email. Talk to you later.